Imagine it's 2 a.m. on Black Friday. Your e-commerce storefront is just buckling under unprecedented traffic.
Oh, the absolute classic developer nightmare.
Right. I mean, inventory databases are falling out of sync, order confirmation emails are lagging by like an hour, and you, the on-call developer, are frantically tracing the failure.
And let me guess, it wasn't a DDoS attack or a database failure.
Exactly. You finally find the culprit. It was an API bridge that snapped simply because someone in the marketing department fixed a typo on a product description page.
Yeah, that tiny update triggers a badly configured webhook, which then just floods your custom middleware with, what, thousands of unnecessary payload requests?
Thousands. And ultimately, it rate limits your entire pipeline. I mean, if you've ever built custom middleware to connect a CMS to external services, you know exactly how brittle those bridges can be.
Well, the maintenance burden alone is staggering, you know? We've sort of accepted this premise that integrating composable systems fundamentally requires standing up servers, writing custom routing logic, managing API keys and environment files across different environments.
And constantly monitoring logs just to ensure a simple content update successfully talks to, like a search index like Algolia or a static site generator.
Exactly. It's exhausting.
Welcome, everyone, to this developer-focused deep dive into Contentstack Automate Foundations, Part 2. If you are joining us, you are probably a developer, an architect, or maybe an engineering manager who is just tired of spending weekends patching custom integration code.
And today's mission is to completely flip that paradigm. We're going to explore how you can orchestrate your CMS as the central nervous system for your entire business logic.
Yes, and doing it utilizing purely visual, event-driven pipelines, literally without writing a single line of middleware. We are tracing the exact developer journey today.
Right, from architecting secure project baselines to engineering highly specific execution filters.
We'll cover handling inbound and outbound webhook traffic and ultimately get hands-on to build a functional automation ecosystem from scratch.
You know, the operational shift here really cannot be overstated. Mastering these foundational concepts means you stop being a plumber connecting pipes and you start being a true architect.
You completely eliminate the infrastructure costs of hosting custom Node or Python integration apps.
And you regain total control over how data flows across your composable stack.
So let's start at the absolute bedrock, which is settings and options. In the Automate ecosystem, before you build any logic whatsoever, you have to establish the Automation Hub project.
Right. The project itself functions as the primary container for your workflows.
But looking at the architecture, the platform enforces configuration settings and authorizations at this project level, rather than at the individual automation level.
Which is a very deliberate design choice, yeah.
And from a developer perspective, my first thought is usually, well, I want granular control per function. Like, why force shared authorizations across an entire project container?
I get that instinct, but the compounding effect of centralized authorization becomes super obvious the moment you consider credential rotation, or even just the blast radius of external API access.
Oh, right, like managing keys across a massive team.
Exactly. Consider a mature enterprise ecosystem. You might have 30 different automations handling various aspects of your marketing pipeline.
Some pushing data to Salesforce, others maybe invalidating CDN caches on AWS.
Right, and others sending notifications to Slack. If you authenticate every single one of those individually, you are creating this massive decentralized security debt.
Because the second the DevOps team rotates the AWS access keys, I have to manually hunt down all 30 automations, open them up, and swap out the credentials.
And if you miss even one, just one, a critical workflow silently fails in production.
And finding that silent failure is just a nightmare.
It really is. So by scoping authorizations at the project level, you authenticate your AWS account or your Salesforce instance exactly once.
Okay, so all automations residing inside that project container just inherit that secure connection.
Precisely. When it's time for credential rotation, you know, that dreaded Friday afternoon chore, you update the API key at the project root. Instantly, all 30 downstream automations are utilizing the new credentials.
Oh, wow. That dramatically reduces your security vulnerability window.
And it guarantees consistency across the board.
It functions exactly like a secure enterprise facility, you know. You don't put a metal detector and a badge scanner at the door of every single cubicle.
No, you put the robust security perimeter at the front entrance of the building.
Right. And once the third-party application passes that perimeter, the project authorization, it can securely interact with the specific rooms, the automations inside.
But this does require strict taxonomy. I mean, you wouldn't put HR records and public marketing assets in the same secure facility.
Which is why defining the scope of your project container is your very first architectural decision.
Exactly. You group automations logically by department or by distinct business functions so that the shared authorizations actually make sense.
You definitely wouldn't want a low-level experimental automation inheriting the production-level database credentials of a core financial workflow.
That would be a disaster waiting to happen.
Okay, so we've secured the perimeter. We have our project container mapped out with the correct baseline authorizations. But an automation just sits there dormant until a system event wakes it up.
Right, it needs a signal.
Which brings us to topic number 2, using trigger conditions to control and automate execution. And honestly, this is where the 2 a.m. Black Friday disaster I mentioned earlier usually originates.
Oh, absolutely. The danger of the naked trigger.
The naked trigger, I like that phrase.
Yeah, in any event-driven architecture, relying solely on a base invocation point is just a recipe for catastrophic system fatigue.
Because if you configure an automation to fire off a native Contentstack entry updated event, the system will execute that workflow every single time a user clicks save.
Every single time.
Which happens constantly. A copywriter tweaks a headline, save. They add an Oxford comma, save.
They swap out an image alt tag, save.
And if your downstream action is an HTTP connector pointing to your CI/CD pipeline, you are suddenly asking your infrastructure to spin up a 20-minute computationally expensive static site build for an Oxford comma.
And you will blow through your cloud provider's compute credits in a matter of days doing that.
Not to mention, if you are hitting third-party services, you will inevitably hit their rate limits and get blocked.
Which is exactly why trigger conditions act as the critical filtering layer. They evaluate the JSON payload of the event before allowing the execution engine to even spin up.
So we intercept the payload, we evaluate it against a set of logical rules, and if the rules fail, the execution is dropped, costing us nothing.
Zero compute cost for dropped executions, yeah.
How sophisticated can we get with these conditions? Because, checking if an entry is published is pretty basic, but enterprise workflows are rarely basic.
Oh, you can build highly complex logical matrices. You utilize JSON pathing to inspect literally any metadata attached to the event.
Give me an example.
Sure. For example, you can build a condition that requires the action to proceed only if the entry language is set to for hide AND, the category array contains enterprise, or the user role of the person saving the entry is strictly defined as senior editor.
Oh, wow. So you can really chain these Boolean operators to create a highly specific invocation profile.
Exactly. It prevents the automation from becoming an attack vector against your own infrastructure.
You're effectively building a gated dam. The event data is always flowing out of the CMS, but the condition gates only open when the exact operational criteria are met.
And the financial and operational safeguards here are immense. You only pay for what you actually need to process, and you protect your external endpoints from getting hammered by meaningless internal CMS noise.
That makes total sense. So we've stopped our internal CMS from shouting into the void by applying those filters.
Right.
But what if the conversation isn't starting in the CMS? What if a Shopify storefront or a custom inventory database or some external cron job is trying to talk to our architecture?
Well, then you need a way to listen.
Exactly. How does Automate actually hear that external traffic? This brings us to step 3, using HTTP listeners.
Right, so Contentstack native triggers look inward at the platform. The HTTP listener connector allows you to look outward.
It functions as an API gateway built directly into your automation canvas.
Exactly. When you deploy a listener, Automate generates a unique, dedicated endpoint URL that's specifically configured to accept incoming webhooks from completely external platforms.
Okay, but my immediate developer paranoia kicks in here. Like, you were telling me we are generating a public-facing URL that executes back-end logic when struck.
Yep.
If someone discovers that endpoint URL, what is stopping a bot network from just hammering it with POST requests and triggering our internal workflows thousands of times a minute?
Well, it's a completely valid security concern, and exposing a naked listener like that would be incredibly irresponsible.
So how do we lock it down?
The listener configuration explicitly requires developers to define authentication mechanisms and header validations before it ever processes the payload body.
Ah, okay. So we can implement HMAC signature verification or require bearer tokens.
Precisely. You configure the listener to inspect the incoming HTTP headers. If Shopify is sending the webhook, Shopify will sign that payload with a specific cryptographic secret.
And our HTTP listener computes that expected signature.
Right. If the headers don't match, or if the expected authorization token is missing entirely, the listener simply drops the request with a 401 unauthorized status.
So the payload never even enters our automation logic, and the execution is never instantiated.
Exactly. It serves as a digital bouncer verifying IDs at the door. If you don't have the cryptographic wristband, you don't get into the club.
I love that analogy. But what about the shape of the data? Like, if I'm expecting a JSON payload with an order ID and some system sends XML or a malformed JSON object, does the listener just break?
Well, the listener itself is designed to be resilient. It will accept the validly authenticated payload, but if your downstream steps are trying to parse a JSON key that doesn't exist, that step will fail.
Ah, so this highlights why understanding the payload schema is absolutely vital.
Exactly, which actually perfectly leads into how we handle the reverse process, sending data out.
Which is our fourth topic. Using the HTTP connector with a publish event. If HTTP listeners allow our architecture to hear the outside world securely, the HTTP action connector allows us to speak back to it.
Right, the HTTP action is essentially your universal adapter.
The source material outlines a very specific scenario here. Using the HTTP connector paired with a native publish event.
Yeah, because while Contentstack has a massive marketplace of pre-built connectors, the reality of enterprise IT is that you will inevitably encounter legacy systems.
Or highly proprietary internal microservices.
Exactly, or niche vendor tools that just don't have a slick drag-and-drop integration. The raw HTTP action allows you to construct any RESTful request, get, post, put, delete, patch, and push the data wherever it needs to go.
Now, the source material heavily emphasizes a specific testing methodology here before ever pointing that HTTP action at a live production system.
Oh, that sandbox testing.
Yeah, they recommend routing the initial automation to a mock endpoint service, specifically webhook.site. Now, as a developer, my instinct is usually to just read the third-party API docs, map the JSON fields I think they want, and fire it off.
Which is a terrible idea.
Right. So why is the Academy so insistent on this sandbox testing step?
Well, because API documentation is notoriously out of date, for one, and blind mapping is just the primary cause of integration failure.
How so?
When a native publish event occurs in Contentstack, the resulting JSON payload is incredibly dense. It contains nested objects, metadata arrays, environment variables, and the actual content fields.
You need to intimately understand the shape of the data you are exporting before you try to ingest it somewhere else.
Exactly. You have to know what's in the box before you hand it over.
So by pointing the HTTP action at webhook.site first,
Huh?
you can execute the publish event and actually watch the raw JSON payload arrive in real time.
Right. You can inspect the headers automate sent, you can verify the array structures, and you can see exactly how the rich text fields are formatted.
It removes all the guesswork. Like if your legacy inventory system requires a strictly flattened JSON object, but you see on webhook.site that Contentstack is sending a deeply nested object, you know immediately that you need to introduce a data transformation step.
Exactly. You do that before it hits the external API, which prevents you from polluting your third-party staging environments with malformed test data.
That visibility is crucial. Testing data flows into a sandbox is one thing, but eventually we have to point these HTTP actions at live production environments.
And that raises the stakes exponentially.
It really does. We need strict governance to ensure technical operations don't outpace business approvals. This introduces our fifth topic, using conditionals when publishing to production.
Now, we discussed trigger conditions earlier, which decide if an automation wakes up at all.
Right.
What we're talking about now is branching conditional logic embedded within the workflow itself, acting as the final gatekeeper before a destructive or highly visible action occurs.
Because waking up the automation might just be step one. Maybe step two is formatting some data, and step three is the critical HTTP POST to the live server.
Yeah, and we want to insert a fail-safe between step 2 and step 3.
Let's consider a practical scenario. Say your automation is designed to trigger a production build on your hosting platform. You absolutely must ensure that the content triggering this build has gone through the proper legal and editorial reviews.
Right. And Contentstack has a robust, human-driven workflow feature for exactly this. A piece of content moves from draft to legal review to approved.
Those are the human governance stages.
Correct. The automation conditional acts as the digital enforcer of those human rules. Inside the automation, right before the HTTP action that hits your hosting provider, you build a conditional node.
Okay, what does that node do?
It inspects the incoming JSON payload and evaluates the specific workflow state of the entry. If the state equals approved entity Z, the target environment array includes production. The conditional routes the flow down the success path, executing the deployment.
But what if someone bypasses the human rules? Like, if a junior editor accidentally tries to publish an entry that is still in draft state directly to the production environment.
Then the automation wakes up, hits the conditional node, evaluates the payload, sees that the state is draft, and routes the execution down the failure path.
The HTTP action is blocked. The deployment never happens.
Exactly. And you can even configure that failure path to trigger a Slack message to the admin team flagging the compliance violation.
It acts like a multi-signature bank vault. The technical key cannot turn unless the business governance key has also been turned.
That separation of concerns is brilliant. The content team manages the rulebook via CMS workflow states, and the engineering team builds the automation to strictly enforce that rulebook without needing to manually approve every single deployment.
Now, we've looked at these concepts: triggers, listeners, raw HTTP connections, and conditionals mostly in isolation. But the source material provides a fascinating use case that combines all these elements into a highly complex asynchronous pipeline. Let's unpack topic number 6, use case, translation with ChatGPT.
Oh, this is where the power of an orchestration engine truly becomes visible. We are moving beyond simple one-way notifications here.
We're building a round-trip, asynchronous data pipeline connecting the CMS to a large language model and back again.
Exactly.
As a developer, if I had to build this manually, I'm thinking about setting up an Express server, writing the webhook ingestion, managing the API connection to OpenAI, writing retry logic in case the AI times out, and then crafting the authenticated PUT request to update the CMS.
That's easily a week of work.
Easily. So how does this look in Automate?
It becomes a purely visual mapping exercise. Let's trace the architecture. The invocation starts with a human action. An editor moves an English article into a specific workflow stage named Ready for Translation.
That's our trigger. The native event fires, filtered by a condition, checking for that specific workflow state.
Exactly. The automation extracts the text payload. Next, it utilizes an HTTP action, or the native OpenAI connector, if you prefer to package that text and send it to the ChatGPT API.
But here's the architectural challenge. ChatGPT is not instantaneous. Processing a large article might take 10, 20, or even 30 seconds.
And in standard synchronous API calls, holding a connection open for 30 seconds is terrible practice.
Yeah, it leads to timeouts and blocked threads.
Which is why the architecture is asynchronous. The initial HTTP action fires the payload to ChatGPT and effectively says, here's the data, process it, and when you are done, send the result to this specific URL.
And that specific URL is the HTTP listener we discussed earlier, waiting quietly on a separate automation path.
Yes. So the first automation does its job and spins down. It doesn't sit there burning compute time waiting for the AI.
That is so efficient.
Right.
Yeah.
Once ChatGPT finishes the translation, it fires a webhook containing the French JSON payload back to your HTTP listener.
The listener authenticates the payload, wakes up the second half of the pipeline, parses the translated text, and utilizes a native Contentstack action to update the original entry with the new localized content.
It can even advance the workflow state to translation complete automatically.
Okay, I have to push back a little here on the reliability of AI, though. ChatGPT is notorious for returning extra conversational text.
Oh, the hypertext.
Right. If my prompt is, translate this to French, the AI might return, sure, here's your translation, followed by the French text. If I just blindly map that entire response payload back into my CMS, I'm going to publish a bunch of conversational garbage to my front end.
That is a critical engineering challenge in LLM integrations, you're right. The solution lies in prompt engineering within the automation itself combined with JSON parsing.
How does that look in practice?
In your outbound HTTP action, you don't just send the text. You structure the system prompt to enforce strict output schemas. You instruct the AI. Return only a valid JSON object with the key translated text. Do not include markdown formatting or conversational replies.
So the payload arriving at our HTTP listener is a perfectly clean JSON object.
Yes. And because Automate allows you to traverse JSON paths, when you configure the final update action, you map it explicitly to the translated text key within the AI's response payload.
You isolate the exact string you need and discard the rest.
Exactly. It fundamentally changes the operational velocity of a localization team. You eliminate the manual export of CSVs, the emailing of translator agencies, and that painful copy-pasting of translated text back into CMS fields.
But building that entire round-trip asynchronous architecture from scratch even visually, takes some serious architectural planning. What if I don't want to wire up the raw HTTP headers and write system prompts?
What if you just need standard integrations right now?
Exactly. Which brings us to topic number 7, automations in Marketplace. While understanding the raw HTTP layer is essential for custom architecture, developers shouldn't be reinventing the wheel for standard sauce integrations.
No, definitely not. The marketplace provides pre-built automations, often referred to as recipes, alongside native action connectors for dozens of enterprise platforms.
We're talking AWS, Lambda, Jira, Algolia, SendGrid, Salesforce.
The value proposition here is pure development velocity. If your business requirement is to invalidate a Fastly CDN cache whenever a global header is published, you do not need to read Fastly's API documentation.
You don't have to figure out their specific token requirements and manually construct the HTTP POST request.
Exactly. You drag the native Fastly connector onto the canvas, authenticate via a standard oath flow or an API key drop, and select your service ID from a dynamically populated drop-down menu.
It abstracts away all the boilerplate API interaction. But, I know some developers hate visual abstraction. They feel it limits their control.
Sure, they want to see the code.
Right. If I use a pre-built marketplace connector, am I locked into whatever opinions the developer of that connector had?
Not at all. The marketplace handles the 80 to 90% of standard use cases beautifully. It solves the common problems instantly. But you are never locked in.
So if a native Jira connector doesn't expose a highly specific custom field our organization requires,
You simply fall back to the raw HTTP connector. You have the ultimate escape hatch. The marketplace provides speed, but the foundational raw tools provide infinite flexibility.
you are never waiting on a vendor roadmap to update a connector. You get the pre-assembled engine when you want to move fast, and the raw gears and pistons when you need to build something totally bespoke.
Exactly. It's the best of both worlds.
All right, we've covered the theory, the security, the asynchronous architecture, and the shortcuts. It is time to move from conceptual architecture to hands-on application. Let's tackle topic number 8, creating a new project from scratch.
Yes. Because before you drag a single node onto a canvas, you have to establish the project namespace. We discussed earlier how projects containerize authorizations, but there is a massive organizational component here that dictates how maintainable your architecture will be at scale.
Right. When you initialize a new project, the system prompts you for a name and a description. Now, in a local testing environment, naming something test webhook 1 is totally harmless.
But the documentation explicitly warns against this in an enterprise setting.
Why is nomenclature so critical at this specific step?
Think about the platform lifecycle. In 2 years, your organization might have hundreds of active automations running across dozens of projects. You will have marketing teams routing leads, engineering teams managing CI/CD, and editorial teams managing translations.
And if an API rate limit is suddenly breached, or a downstream database starts receiving corrupted payloads, the DevOps team has to audit the platform.
And if they log in and see 30 projects named Integration V2 or Content Update Tool, they have absolutely no idea where the destructive payload is originating from.
They are completely flying blind.
Exactly. A strict, standardized naming convention at project creation is mandatory governance. A project should be named descriptively, such as your region marketing-led routing.
And the description field must detail the exact services connected, the primary owner of the pipeline, and the expected business outcome.
Right. When that 2 a.m. crisis hits, the DevOps engineer can instantly identify the blast radius and disable the offending project container without disrupting the rest of the enterprise architecture.
It's all about building observable infrastructure from day one. Okay, so we've established our highly descriptive, secure project container. Let's move to topic 9. First, automate project walkthrough. We're going to wire up a foundational data flow.
The goal of this first walkthrough is to understand how data passes from node to node without writing variables.
We start by configuring the trigger. We select the Contentstack native connector and set the event to entry update.
So we are catching the payload of the updated entry. And as we established, we immediately apply a condition rule. We inspect the payload and assert that the target environment does not equal production.
We are isolating this workflow to staging events to prevent noise.
Right. Now for the critical mechanism. The action step. We want to send a notification to the engineering team via a Slack connector.
In a traditional Node.js script, you would declare a variable, assign it the value of the entry title from the parsed JSON payload, and then inject that variable into the Slack API payload,
But Automate handles this via visual mapping.
which feels like magic the first time you use it.
Yeah.
When I configure the Slack message body, I don't write any syntax. I just click an Insert Data button.
And the platform exposes a complete traversable schema of the JSON payload captured by the trigger step. You visually expand the payload tree, locate the specific custom field, say, the article title, and just click it.
And Automate instantly maps that specific JSON path right into your message field.
It handles the variable interpolation under the hood. If the title changes in the CMS, the mapped data updates dynamically in the subsequent execution.
It entirely removes the risk of syntax errors when traversing complex data structures.
It really allows developers to focus on the logical routing of the data rather than the boilerplate syntax of extracting it.
Which brings us to our final segment, topic number 10, Exercise Review, your first Automation Hub project. Let's solidify the underlying technical reality of what we just built.
Because while visual mapping is incredibly user-friendly, a developer needs to know exactly what is happening at the code level to debug complex flows.
Exactly. Visual abstraction is excellent, but you must understand the underlying schema. When you utilize that visual mapping tool to select the article title, you are interacting with a highly standardized JSON structure generated by the Contentstack trigger.
And the critical technical takeaway from this foundation is understanding the specific path to your content.
The source material heavily emphasizes a specific syntax string for this, body.data.entry.
Yes, body.data.entry. When a native CMS event fires, it wraps the actual content in layers of metadata information about the user who triggered it, the workspace ID, the timestamps.
All of that is necessary context, but usually what you actually want to route to your third-party service is the content itself.
Right. To reliably extract the specific fields the author wrote, your data mapping must target the body.data.entry object within the payload.
So body.data.entry functions exactly like a FedEx tracking number. The trigger drops a massive shipping pallet of data onto your loading dock. The metadata is the manifest on the outside of the pallet.
But if you want to open the specific box containing the actual article text, you have to use that exact body.data.entry string to locate it.
And the brilliant part of this architecture is its consistency. While external APIs from disparate vendors will always require different shapes of data, the internal payload structure originating from Contentstack is immutable.
Whether you are catching an entry creation, an update, or a publish event, the content will always reside within that body.data.entry path.
Once a developer internalizes that schema, they can effortlessly extract and manipulate data across hundreds of different automations without having to constantly inspect the logs to find where the content is hiding.
It really provides a stable foundation for complex routing.
We have covered an immense amount of architectural ground today. We started by designing secure perimeters with centralized project authorizations, effectively solving the credential rotation nightmare.
We engineered trigger conditions to act as financial and operational fail-safes, preventing CMS noise from overwhelming our infrastructure.
We moved outward, deploying HTTP listeners as secure API gateways with strict header validation, and utilized HTTP actions paired with webhook.site testing to construct resilient, outbound data integrations.
We implemented digital enforcement of human governance using branching conditionals for production environments.
We unpacked the asynchronous architecture required to integrate large language models without hanging our execution threads.
And we balanced the speed of marketplace connectors with the raw power of custom HTTP requests.
Finally, we established the enterprise naming conventions necessary to make all of this observable and maps the critical body.data.entry payload structure.
The foundational tools are now in place. You have the ability to catch, validate, transform, and route data anywhere on the web, securely and asynchronously.
Which leads to a profound operational shift. I want to leave you with a final thought to mull over. For decades, developers have viewed the content management system as a passive repository, a dumb database holding text and images waiting to be queried.
But now that you can route raw JSON from the CMS to any external service, conditionally evaluate logic, and process asynchronous responses without writing a single line of custom middleware.
Consider this. Is your CMS still just a storage walker? Or, through event-driven automation, has it actually evolved to become the central nervous system orchestrating your entire business logic? Thank you for taking this deep dive into Automate Foundations. We'll see you next time.